Now, activity of the radioactive sample, that is A or R. So, activity is expressed by a symbol A or R. The number of decay per unit time or decay rate is called activity. More elaborately, this activity is called the radioactivity. Well, activity is given as dN over dt, that is n naught lambda e to the power minus lambda t, and it is simplified further, and it will become n lambda. N naught lambda is equal to A naught is the initial activity. A is equal to A naught e to the power minus lambda t, the activity law which shows activity decreases exponentially with time, which I have just now discussed. As the time goes on increasing, the number of atoms will start decaying, so it will become n naught by 2, n naught by 4, and so on. So this is indicated in the activity here, time increasing and activity, that is, if time is right starting, activity is more. If the time is moving towards, that is on the x-axis, towards the extreme right, the activity will be dropping towards the 0 of y-axis. Activity is proportional to the number of active elements, active atoms, that is A into mu n, which depends on the mass of the radioactive sample. So because if the mass is more, obviously the number of atoms will be more. The activity of 1 gram of radioactive substance is called specific activity. Half-life is the time in which activity of radioactive substance is reduced to half. Already the concept is discussed. Mean life is the time in which activity reduces to 37% of the original value. So we have mentioned a law earlier, that is average life is 1.44 times of half-life, or TA, average life divided by 1.44, that will be equal to half-life. The variation of activity with time is A over A naught equal to 1 over 2 power small t over capital T, where T is the half-life, T is the time instant in which A atoms are existing. Now, units of activity, as I have expressed right in the very beginning, that activity depends upon the rate of disintegration. Larger the rate of disintegration, larger will be the activity. And as the disintegration goes on increasing, the activity goes on dropping. And this activity is expressed either in Becquerel or Rutherford or in, Curie. So the definition is already given, that is 1 gram of radium-226 is called 1 Curie, and 1 Curie is 3.7 10 to the power 10 disintegrations per second. The other unit is Rutherford, that is 1 Rutherford is 10 to the power 6 disintegrations per second. Becquerel. So earlier we have discussed Rutherford, and now we are coming towards Becquerel. This is the smallest unit. 1 Becquerel is 1 disintegration per second. So we can relate the 3 units, Curie, Rutherford, and Becquerel, but all of them run the disintegrations per second. That is, number of atoms breaking per second, or the number of nuclei breaking per second, because one atom can only have one nucleus. Pair production and annihilation, as I have explained, in the pair production, energy transfers to matter, or it is converted to matter, and in annihilation, we find that the matter converts to energy. So, in the pair production, we normally find that a gamma rays photon with energy 1.02 MeV, it splits up into a positron and electron, that is called pair production. Energy is converted to mass. And in annihilation, what we find, 1 electron and 1 positron. Or similarly, particle and antiparticle, they interact, and as an interaction, the resulting component will be a photon of gamma rays of 1.02 MeV, or there will be 2 photons of gamma rays, each with energy 0.51 million electron volt. But the total energy will not exceed 1.02 million electron volt. Now, the main concept is collision of gamma rays, photon by nucleus, and the production of electron-positron pair is known as pair production. The rest mass of each of electron and positron, that will remain 9.1, 10 to the power minus 31 kilogram. So the rest mass of energy of each of this will be given by function, that is Einstein equation, E naught is equal to m naught c square. We compute the value and the value come to 0.51 million electron volt. However, it is calculated in joule, but then joule is converted into million electron volt. So it is shown in the image or the diagrammatic representation. H nu is in the form of wave, Z is the nucleus, Z is atomic number, E is the charge of that nucleus. So when the nucleus splits, we get one positron and one electron. Minus 1 beta 0 electron plus 1 beta 0 is positron. So energy is converted into mass. So this is what we are finding. This is called pair production. Hence the pair production, it is essential that the energy of gamma rays must be 2 into 0.51 or 1.02 million electron volts. So it is all indicated in symbolic form here, and in the right side portion we find that gamma photons H nu, then another gamma photon H nu, but each of them energy 0.51 after combining. And before combining it is plus 1 beta 0, minus 1 beta 0. We are referring to positron and electron.